So our first one up is we want to find the value of x. Well, you know the value of this angle is going to be what? 3x equals? Opposite angles in a parallelogram are congruent, so this has to be 90. So you're going to have 3x equals 90. Divide that 30. 5 by 3, and you get x equals 30. Nice job. Our next one up over here. Again, it tells you it's a parallelogram. You know the opposite sides in a parallelogram are congruent. So we're going to have 18 equals 6x. We're going to divide by 6. X equals 3. Okay, so again, our definition of a rhombus is a parallelogram with all sides that are congruent. And your properties are that the diagonals bisect a pair of opposite angles, and each diagonal is the perpendicular bisector of the other. So rectangles, a parallelogram with 4 right angles, and the diagonals are congruent. So on your sheet, this should be 1, and this one should be 2 on your flow chart. Okay, so a square is a parallelogram that's both a rectangle and a rhombus. It has 4 congruent sides and 4 right angles. And then the property is that the diagonals form 4 congruent isosceles right triangles of 45, 45, 90s. That in the picture that we have our diagonals being perpendicular bisected. So we know that this has to be a rhombus. Okay, so in a rhombus we know several things. I'm going to go back at my flow chart. We know that all sides are congruent. So we know here the value of AX, I'm going to fill that in, is 12. We know the value of DX is 5. We know the value of AD to be 13. So if you know all sides are congruent, that means we know that DC is 13. It means that we know BC is 13. It means AD or AB is 13 because all sides are congruent. So let's see which one of those I need to fill out on here. BC 13. DC 13. I think those are the only 2 spots. Okay, after that, we know that the diagonals are bisecting each other. So AX is 12. XC has to be 12. Okay, if DX is 5, that means that BX also has to be 5. So if we want to find the length here, where did that go? All right. 5. So what's the whole length of DB? 10. And AC would be 24. Nice job. Okay, so here, when we look at this, we know that this is a rectangle. And you don't know that, but I know it. You should write that down. Rectangle. And we know that our diagonals are being bisected. Okay, and they're going to be the same length. So we have this going on right here. So using the fact that we know these are alternate interior angles, we know angle 4 has to be 32 by alternate interior angles. And then over here, we can find angle 3 because we know we know in a rectangle the angle is going to be, and the corners are going to be right angles. I ruined that surprise. So 90 minus 32. What's 90 minus 32? 58. Because these are going to be congruent, means that these angles, our base angles, are going to be congruent. So angle 3 is 58. That means angle 1 has to be 58. And then to find angle 2, we have a triangle there. So we take 180. We subtract our 2 angles that we know. 58 minus 58. So it's going to be 180 minus 116, I think. Have somebody use a calculator to calculate that for us.
Wait, how do you know angle 1 is 58?
You say what is...
So based on the fact that we know that these here are going to be congruent, that the angles opposite them have to be congruent. 64. Okay. Ooh, I put that in the wrong spot. 64. Okay, and then our last one's KTN. KTN is going to be what angle measure? So KTN is going to be, is that right angle, right? So it's going to be 90. And then our other one is TNE. That's this angle here. So how much is this one going to be? It's going to have to be 90 as well. We know here that this is going to be a rectangle again. I'm going to have you add that in. Rectangle. This is still a parallelogram, so we know opposite sides are congruent, so that means that DC has to be
4.
okay. So this has to be 4, 4. And we know that we have this value over here, AD, which is going to be 3. Okay. Now that we have that, we are going to have to solve for our diagonal. You have a triangle right in here. What can I do to solve for this triangle alongside the hypotenuse?
Oh, A squared plus B squared.
A squared, excuse me, plus B squared equals C squared. Pythagorean theorem. So 4 squared plus 3 squared equals C squared. 16 plus 9 equals C squared. What's 16 plus 9? 25. Equals C squared. We're going to square root both sides. C equals 5. So we see that C equals 5, which is my hypotenuse. So that's going to be AC. Inside a rectangle, we know diagonals are going to be what? Congruent. So that means that BD also has to be 5. And we know that CX has to be how much? 2.5, because it's half of your diagonal divided in half because it's being bisected. 2.5. Yep, nice job, guys. So this is a rectangle, so we want to find angle 1. How do I find it? Yep, because we know it's going to be a right angle, so it's going to be 9A minus 21. Which is going to bring me to 69 degrees. And then we want to find angle 1. Or we know it's angle 1, so angle 2 has to be? It's going to have to be the same, right? Because we know that these are going to be congruent. So that means that this angle and this angle are congruent. So this is also going to be 69 degrees. That brings us to angle 5. We know that one also has to be 21 because opposite sides of congruent, or opposite angles of congruent sides are congruent. Yep. So if I wanted to find angle 3, how do I find it?
180 minus 21 minus 69.
So angle 3 would be 180 minus, and then this angle here was 69, and this one was 69. So minus 69 minus 69. 42. Okay, and angle 4 is this one. So we're going to do 180 minus 21 minus 21. Those are the two angles we know here. 138. Thank you, guys. Okay, so here you guys see that this is a square. So what do we know about squares? What do we know about all the sides? They're going to be congruent, so all these are going to be 12s. So let's see how many of those we can fill out. We know that AB is going to be 12. We know that BC is going to be 12. I think that's all that we have here. But I also had something that I told you guys to like write down on your flow chart about squares. There's no spot for it, but you guys added it at the bottom. What was it?
245.
They form 45, 45, 90 triangles. So what you're seeing is that this is going to be 45, 45, 90, 90, 45, 45, 90, 45, 45, 45, 90, 45. So you see these are all going to become 45, 45, 90s, which is a special right triangle. You guys may remember from our last chapter. 12, 45, 45, 90. There's a way to get those side lengths. If you guys remember the trick, what do we do with that?
Subtract
Not subtract. So our trick was we took our hypotenuse and we divided by 2. And then you attach the square root of 2 to it. If you don't remember that, you guys can go through the steps of 12 equals a square root of 2. Divide by the square root of 2. You end up with a equals 12 divided by the square root of 2. Rationalize top and bottom by the square root of 2. It gives you 12 square root of 2 over the square root of 4. What's the square root of 4? 2. Which brings us back to 6 square root of 2. So if you didn't remember that, and that means that all of these little legs inside here are going to be 6 square root of 2. 6 square root of 2 6 square root of 2, 6 square root of 2. And then now we can fill out what we know. So we know that dx has to be 6 square root of 2. We know that ax has to be exactly right. Bx is going to be 6 square root of 2, yep. And then now we have the whole diagonal length, db. So it's going to be both parts, so that's going to be 12 square root of 2. Because it's just going to be 6 square root of 2 plus 6 square root of 2. You're fine. And we know diagonals are congruent, so we know that this one's going to be 12 square root of 2 as well. And then we want to find these angles. So AXB. So AXB, that angle is going to be 90. And then we have XAB. So XAB is this little angle right here. So 45. And then XBA. XBA, yep, 45.
We're done.
Yay.